So we are continuing to look at percent composition, and I'm going to work three different example problems to just refresh and clarify as needed. So if we look at the first example, what I have here is 9.03 grams of magnesium combined completely with 3.48 grams of nitrogen. And what I want to find is the percent magnesium in this compound as well as the percent nitrogen in this compound. And if we know anything, percent composition is just like regular percent. So we're going to take the part that we want, which one part is going to be magnesium, one part is going to be nitrogen, over the whole thing, which will be the magnesium and the nitrogen together, times 100. Okay, so what does that look like? Let's do percent magnesium first. All right, so for percent magnesium, it's going to be the mass of the magnesium that's in this compound, which is 9.03 grams, divided by the mass of the magnesium and the nitrogen, which is going to be 12.51 grams times 100. And then to finish this out, we would just take 9.03, divide that by 12.51 times 100, of course, and we get 72.2%. There's one of two ways you can find the percent nitrogen in this compound. You could put 3.48, divide that by 12.51 times 100, or you can just take 100, because the percents add up to that. 100 minus 72.2, and then the percent nitrogen is the leftover. Percent nitrogen is the leftover, which is going to be 27.8%. Okay, and so that is example one. That's one way you will have to deal with percent composition. Example two is the traditional way. I have a formula here, and I want to find the percent composition, the percent carbon in this compound, and the percent hydrogen in this compound. So the first thing I need to do is know the molar mass of this compound. So I do that by adding together the mass of 2 carbon atoms and 6 hydrogen atoms. And so I get those masses from the periodic table. I add them together. Give me 1 second here. And so the total mass, molar mass of this compound is 30.0697 grams per mole. Okay, I ran out of space there. So to find the percent carbon, what I'm going to do is I'm going to take the mass of the 2 carbon atoms divided by the mass of the entire compound times 100. Okay, and so to get started, I do the mass of the 2 carbons, which is going to be 24.022 grams per mole. I already calculated the mass of the entire compound, which is 30.0697 grams per mole. And then I'm going to multiply that by 100. And so when I go through that process, 24.022, divide that by 30.0697, of course multiply it by 100, I get 79.9%. So that's the percent carbon in this compound. Once again, I can take the mass of the 6 hydrogens divided by the total mass to get the percent hydrogen in this compound, or I can go through and say, well, the percents will equal 100. If carbon is 79.9, then what I'm going to do is take 100 minus 79.9, and that will give me the percent hydrogen in the compound, which is 20.1%. All right, so that's example number 2. And then our last example, number 3. I actually want to find the mass of hydrogen that's in 350 grams of C2H6. So fortunately, I just calculated the percent hydrogen in that. So if 20.1% of this compound is hydrogen, then I need to just figure out, well, what's 20.1% of 350? All right. And so to do that, the first thing I'm going to do, well, first let me just put this here. The percent hydrogen in the compound is 20.1%. Okay. And so I'm going to find 20.1% of 350. And so remember, whenever we do that, we have to convert this from percentage to just a regular number. And so that becomes 0.201. And I multiply that by the 350 grams, which is the mass of the whole thing. And so 0.201 times 350, 70.4 grams of the 350 grams is hydrogen. And that's the third example.